Hi there everyone. We're here today to look at an idea called unit analysis. Now this is an idea that is quite powerful after we've done a lot of algebra. Sometimes it's really easy to make mistakes algebraically, and one way we can check to see if we've done our algebra correctly is to do a process called unit analysis. So let's go over and take a look at an example. So I was working on a problem the other day, and this was an equation that I came up with after many lines of substitutions and cancellations and whatnot. I finally derived this equation from some things, and this was the idea here was to find some initial or original velocity. And as you can see, it's pretty complicated. With a lot of steps, it's very common that we could make a simple algebra mistake. So at this point, this is where I said, I want to check this thing out and see if my unit analysis actually works for this. So let's run this through unit analysis to see if it actually works out. So the first thing I want to look at here are the different quantities that have units. G represents the acceleration due to gravity, and it would have units of meters per second squared. We also have delta x, which is a displacement in the x direction. If we're in the SI system, we're going to be in meters. On the bottom of our fraction, we have 2, which is a constant, so there's no units here. We have delta y, which is a displacement in the y direction, and delta x again. So here we're going to be taking a meters plus a meters. This trig function tangent has no units. So we will be basically in the bottom here adding a meter plus a meter. Now, something also note is that this entire expression is within this root symbol. So we need to also include that as part of our unit analysis. So working this through, if I work through the top first, don't forget meters is like meters over 1. So we're going to end up multiplying the top two things here, where we're going to have meters times meters, going to give us meters squared, and of course on the bottom we'll have seconds squared times 1, and that will of course give us seconds squared. So on the top part of this fraction, I want a different color. Let me get rid of that and go with black. We're going to get meters squared per second squared, and on the bottom, when I add a meter plus a meter, I am going to get a meter as well. And don't forget, this is in the root symbol. Now when I work this through also, I can think of again this meters as a fraction, and one thing I can do here, maybe the way to look at this, is to take meters squared per second squared, and we're dividing it by another fraction, so that is like times the reciprocal. So that's times 1 over m. Now, we have an m here. That's going to cancel out one of the m's here, and we're left with 1m on the top. Going down to my next line, I have the root symbol still, and I'm going to have a meter over seconds squared as my unit. If I take the square root of this, I'm actually going to have root m over seconds as my final units. So, just to recap, we ended up with these units right here, which looked kind of strange, especially considering we were expecting a velocity. So when I see this, what I think is this is a red flag. Okay, I would have expected a meter per second. So this is showing me that there was something that I've done algebraically wrong in my equation. So I went back and checked it. So after further review of my algebra, I realized that up in this equation here, I had actually forgotten, I had dropped a squared from the delta x, and that would of course make the difference here, and it would actually give me meters per second as my overall unit for this. Now let's talk about some limitations for this idea of unit analysis, because it's not a perfect method, but it's going to help us catch some errors, but it will miss some. So let's talk about that. So the first part is that the unit analysis is not going to help us when it comes to the unitless parts of the equation. And what am I talking about? Well, if you notice in our equation that we just looked at, there was a trig function. Trig functions are unitless, and therefore if I messed up a trig function, if I use sine instead of cosine, unit analysis is not going to help me out with that. The second thing that is unitless are constants. So again, if we go back to our equation from before, we noticed there was a 2 in there. That 2, if I made an algebra mistake somewhere and that was accidentally and inadvertently put in there, that would actually not work as well. Secondly, it is possible actually to get the correct unit even if you have the wrong equation. Again, potentially if you've done the algebra and you've put quantities in certain places that might give us the same units, it wouldn't actually show that in a unit analysis either. Chances are that's unlikely to happen, but it is slightly possible that could happen as well. So in conclusion, a unit analysis is a very powerful way, after we've done quite a bit of algebra, to just one way to check to see if we actually might have the right equation in the end.